Want to create some images programmatically from Java? That's what this video is all about. Welcome to Tales from the Jar Side. The OpenAI API is available here. I'm currently looking at the API reference inside platform.openai.com. So I went into the documentation and tried to find how do you access this RESTful web service, because I'm simply going to do that programmatically in Java. To create an image, there is the URL you need to access, and as you can see, you need to do a post request on that and supply your body of the request with JSON data. Now this one is actually very simple. It's a little hard to see in the dark background here, but let me tell you what's in there. So you see the curl request that they're showing as a demo has in there an object that has a prompt. There's our text, the prompt itself, n, which is the number of images we want generated, and then a size. And over here in the documentation, they point out that the size is one of either 1024 by 1024 or 512 by 512 or 256 by 256. So there's only three options there, and they're all square. Now, what's really interesting to me is what's not in there. You could see in the request body options, you do have to put in the prompt. N defaults to 1, but you can pick any number of images to generate between 1 and 10. And the size defaults to the big one, fine. But the response format is the one I find interesting, because it defaults to URL, but it can be a base 64 encoded JSON string. And this means that if I was to use the URL type inside this, then when I got back my response, I'd have to do an additional query. I'd have to go to that URL to download the image. And the images don't last long on the server. And besides, why do I even want to do that if instead of doing the response format of URL, I could say just include the image encoded in the output? Now, the response that comes back, you see down here in this example, is extremely simple. It says we have to get a created timestamp, which fine, I don't need that. And then we have a data property, which is an array of either, as you're seeing here, URLs, that would be the URLs to the various images, or if I use the other response format, this will be the base 64 element. And up here you can see this is what the image object looks like. You either have a URL in it, or you've got this base 64 encoded JSON string right inside that. So there's the idea. I want to make this call programmatically. I want to get back this response. And for each of the images in there, I want to extract the base 64 string, save it into a ping file, some kind of image file, and then take a look and see what I got. And I'm going to use Java 17 tools to do it. Let's take a look at the code. Now, the first thing I do whenever I do projects like this is I map those JSON structures to Java records. Records work really well for this sort of thing, and I can use a JSON parser to convert the JSON data to records and back very, very easily. So the request, I called an image request. It's a record here. And I'm going to put in my string prompt, the number of images I want, the size. I put in a documentation string here to point out what the options are. At some point, I may convert that to an enum just to make sure that only the valid ones are there. But right now, I just am going to put in a string, and I'll specify the response format. Now, the response that comes back simply has the long, that with the created timestamp in it, and a list of images. And you could say list or array, both of them will work with most of the major parsers. The image itself simply wraps that base 64 JSON string. Now you might notice, like right here, I'm using camel case in Java, whereas we just saw the JSON data uses snake case, lowercase with underscores. Well, when I go to my program here, let's take a look. In my Dolly program, first of all, I've got the URL that I'm accessing, but this is how I can get Google's JSON to do the switch from snake case to camel case for me. So I use a JSON builder. I set the field naming policy to lowercase with underscores, and this will automatically convert camel case in my Java records and classes into snake case for the JSON request and response. So my method here to get all these images is going to take that prompt and an integer, the number of images I want. What I'll do is I'll instantiate that record, the image request record with the prompt, the number of images. At the moment, I've hard-coded it in to 512 by 512 and my response format as well. That's kind of what I'm expecting, the base 64 encoded JSON data. So now I need to send that and get back an image response. Now, before I show you how I process that, here's the way to send the request. It's kind of verbose because everything in the HttpClient API in Java 11 is kind of verbose, but at least it's all kind of routine as well. Up here, I skipped over this, but there's the builder to create the HTTP client itself. Again, the HttpClient API was added in Java 11. So if you're at 11 or above, you've got this available. So to make the request, I specify the URL, wrap the string inside a URL create, that works. And I'm added, the one header that I have to add is the authorization header. Now this has the word bearer followed by my OpenAI API key. I save that key as an environment variable so that I don't accidentally check it into source code control or something like that. This will set the header with that authorization in it. Now I also went and set the content type header and the accept header, basically telling the server that I'm sending JSON data and I'm expecting JSON data back. I don't know how necessary that was, but it doesn't hurt anything. It just seemed like a good thing to do. What I do need to do is call the post method so that I send a post request, and this mechanism is what you use to put in the body of the request the JSON version of the request. I use the JSON object to convert the request into JSON data, pack it into the body of the post request, and now I've got the HTTP request. In the try block here, I'm going to send that request, and what I get back, I'm going to say, just give me a string version of that. So I'll get an HTTP response of the string, and I'll print out the status code just to let me know everything seems to be okay. And now I use JSON again to convert the body of the response into one of those image response records, and I'm good. That's really all I have to do. It just takes time to run, but that's about it. Now let me show you, getting back this response, how I'm going to post-process that and convert it to files. Part of my getImages method, after sending the image prompt and getting back the response, is to then access the data property inside the response. Remember, that's going to be the list of images. I'll make it a stream. I'll map each image to that B64 JSON property. And then I'm going to write each one to a file. Now I used a filter here because I'm going to have write image to a file return a Boolean just so I can count at the end how many images I actually managed to save to a file. So let's take a look at that method. Now this has nothing to do with GPT or anything like that. This is just basic file I/O using the new I/O mechanism and everything. I'm going to take that image data, and here I needed a unique file name for each image, and I want to save some of these images that I like. So in order to come up with a unique name, I put the word image on there. This string here is a formatted current timestamp with year, month, day, hour, minute, second, all in there, plus a counter. The counter up here just starts at 1, and that way if I ask for like 4 images, then they may all have the same timestamp, but they'll be labeled 1, 2, 3, 4. That way I can keep them all separate. So this paths.get and directory.resolve and files.create directories, that's all a way of creating the file on my file system. I'm putting everything under source main resources. Here's the fun part though. Java has a class called base64. Base64 has been around since Java 1.8. In that class, there's a method called getDecoder, which returns a decoder that decodes using the basic type base64 encoding scheme, and I simply supply to the decode method the image data, and what that does is it takes the source, the base64 encoded string, and returns an array of bytes, converts it to a byte array. Then I could use files.write to write the bytes into that file, making sure I create a new one. I'll print out that I saved it. I'll return true for all the ones that were successful, and now we're good. Let's actually test it and see what kind of images we can get. Here's my test. All I have is one single test in here. I'm going to call get images. Here's a Java text block, the multi-line string introduced in Java 15. It says a realistic photo of a robot leaping into the air in joy after accomplishing a difficult task successfully. I'm going to get back the number here. That was part of the count. I'll print out how many images were downloaded, and I'm going to assert that this is going to work. I'm going to send 2 and assert that I get back 2, and let's hope for the best. Let me run this test now. Now that took a handful of seconds, 5-6 seconds, something like that. I've cut it out of the video because you don't have to stare at the screen for that time. But the idea is that the print said, yep, we got a 200 status code, everything worked. Here are the images that were downloaded and saved into resources. Let's take a look at the images. So here in my source main resources, the last 2 are going to be the new ones. There's the robot leaping into the air, and there's another robot leaping in the air. That one's kind of funny looking, but okay, I got them. And that's it. That's how easy it was to actually incorporate the DALL-E image generator into a Java program. Just for fun, let me finish off by showing you an image carousel. Now this, I have to admit, I had to work with GPT-4, or actually what I used was the AI assistant inside of JetBrains to help me write some JavaFX code. I don't have that much experience with JavaFX, and it helped me come up with this image carousel program. So this is using a stack pane and a list of images and an image view, and here I'm going to set a scene and scale everything appropriately and do the animation. Again, this took a little bit of doing. I'm not going to worry about the details. Now, in order to run a JavaFX program, I have a bunch of dependencies I have to manage, especially JavaFX. I find for me the easiest way to do that is to go into my Gradle build file and add a JavaFX plugin inside there. Now, I'm also going to add the application plugin in Gradle because that will allow me to say, here's the class with the main method in it. So when I call the run method in Gradle, it will execute that main method with all the dependencies set up properly. And now let's take a look at that. And what we see here is a carousel of each of the images that are in that directory that I've downloaded before. I like that one, that's a good one. Showing all the robots one by one, pausing for 3 seconds and going to the next one. And it's rotating indefinitely, so what the heck, I don't mind. I can let it just crank away and show whatever ping files I happen to have inside that directory. There you go, that's everything. All of the code that I've talked about in here is in the GitHub repository that's listed in the description. I hope you enjoy it. The next video in this series, I'm going to adapt this and use the Spring framework. Now, Spring has an OpenAI API in the works, but I can use Spring now to eliminate a lot of the networking boilerplate and just use the new HTTP interfaces inside of Spring. So stay tuned for that one. If that one's already available, it'll be linked in the description now. Thank you very much. Take care and have fun.